good morning, everyone. It's a great pleasure to get to spend the next 15 minutes talking about data science with you. My name is Nicos Savva. I've been at the London Business School for 12 years. And in a sense, I describe myself as a data scientist who's found a home in a business school. So 12 years ago, when I first started here, data science was a niche topic. We offered pretty much 0 electives on it, very little teaching, and it was called statistics. Fast forward 12 years, we have a number of data science electives that range from sort of, machine learning and data mining to sort of, analytics that involve simulation, optimization, and so forth. And it's one of the fastest areas of growth for the school, and our electives are very well subscribed. So we're venturing into offering sort of similar courses for more senior executives in executive education. And in a sense, my 50 minutes today is a high-level overview of what data science can do. So I'm going to keep it more on the conceptual level than the actual sort of, methodology level. I'm going to spend maybe 10 minutes trying to show you how you do data science rather than talk about this. And I'm going to give you a little data science assignment. So if you thought that you were just going to listen and not do anything this morning, that's not the case. So here's my little data science assignment for you. So it's based on the game of Russian Roulette. You familiar with this game? I see some sort of, Not practically. I mean, you probably wouldn't be as successful as you are in your careers if you were engaging in this game often. But basically, the Russian Roulette game is a game of chance, allegedly popular with officers of the Bolshevik army stationed in places like Siberia, where my understanding is that there was not a lot of things to do. So in order to get some excitement, they would take a revolver that looks a little bit like this. They would place one bullet in sort of one of the chambers, sort of spin it, take bets, and sort of, put it to their head and press the trigger. And that would generate sort of, an adrenaline boost, excitement. They would win some money as if they actually won, so they wouldn't be bored anymore. Or the gun would go off, and again, they wouldn't be bored anymore. So win-win situation. So obviously, we can't play this game because of health and safety reasons, and also sort of, shooting each other is probably not good business practice. So let's play a thought version of this game. So in my thought version of this game, to make it a little bit more extreme, I'm going to ask you to think about a revolver with 6 chambers, and I'm going to place 3 bullets in the chambers in consecutive chambers. Okay? So 6 chambers, I'm going to place 3 bullets in consecutive chambers. And I'm going to give you a choice. This is your data science assignment. Would you rather sort of go for A, spin once, and then shoot, shoot, shoot? Or would you rather go for B, which is spin, shoot, spin, shoot, spin, shoot? So in both cases, you're shooting 3 times, okay? And in both cases, there are 3 bullets in consecutive chambers. And the question is, would you rather to go with A, spin, shoot, shoot, or B, spin, shoot, spin, shoot, spin, shoot? Do you want to think about it for a few seconds? Well, I have some water. It's very important to sort of structure these breaks. Who thinks A, spin, shoot, shoot, shoot is the right choice? 1, 2, 3, 4, 5. Who thinks spin, shoot, spin, shoot, spin, shoot is the right choice? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20, 21. I would call it around 25 plus or minus 5. Because that's kind of the level of confidence I have on my ability to count numbers that are greater than 5. When I teach data science, I typically start by playing this game with the audience. And typically, the split is something like, 20-25% of the people go for option A, and sort of 75 to 80% of the people go for option B. So who went for option B that wants to sort of explain quickly why they did this? Yes, sir?
Each probability is independent.
Okay.
So you reset
So you know, the first time I spin, that's like a 50% chance of getting into sort of a loaded chamber, which is not so good, and a 50% chance of surviving. So the first time I do this, I have something like you know, a half or 3 out of 6 probability of surviving, times 3 out of 6, times 3 out of 6, because every time I spin, provided I survive the previous time, I reset the probabilities to sort of a half, which gives me a probability of surviving, which is 1 over 8. Okay, that's I agree with this analysis. What about option A? Yes, sir.
Well, I'm Russian, so...
Context experience, yes.
And I'm also a mathematician, so I know that if I did math, so the probability of staying alive in chance A is 1 over 6, which is more than 1 over 8.
All right, so let's analyze this a little bit better. I don't know if it's the Russian part of your sort of, you know, background or the mathematics part that helped, but there's certainly sort of some truth to this. So let's think about sort of, you know, the chambers of the gun. So if I spin the gun and I land on chamber number 1, what happens? Bang. 2, bang. 3. If I land on 6, click, bang. 5, click, click, bang. But if I land on 4, it's click, click, click. So there is one chamber out of 6 that if I happen to be lucky enough to land on this, I survive for sure, and then another 5 where I die either immediately or after a little bit of suspense. So basically, the chances of surviving here is 1/6, and sort of if you prefer to think in terms of percentage, that's something like 12.5%, and this is something like, what is it, 16.667? Something like that. So in a sense, relatively speaking, this one has a 25% chance higher of surviving, or if you want to think about this in terms of investments, the return on investment will be about 25% higher if you chose A rather than B. Okay, so why am I giving you this little assignment, do you think? Or what am I trying to get out of this? What am I trying to communicate? I guess the first point that I'm trying to communicate is that our intuition, which has been sort of, you know, developed over sort of, you know, millennia of life in a savanna where we had to sort of, you know, hunt for animals, protect ourselves and our offsprings from attacks from lions, sort of, you know, find partners to sort of, you know, pass down our genes and so forth. The evolutionary forces that develop this intuitive understanding we have about this world are not particularly good in making trade-offs that involve probabilities. So our intuition, yes, is great for many, many things, but not necessarily for sort of, you know, making choices about investments that involve risk, uncertainty, especially dynamic ones that evolve over time. So that's kind of the first point. The second point is that sort of, you know, a little bit of analysis gets you a long way. So what did we do for analysis here? Well, we built a little model of a gun. And if you look at this model of a gun, does this look like a gun? Does it have the shape of a gun, the weight of a gun? Does it fire bullets? No. It simplifies a lot of the things that make the gun what it is, but retains the one feature of a gun that's relevant for the problem at hand. And this is the chambers of the gun, and the ones that are loaded and the ones that are empty. Now, based on this simplified version of reality, which we typically call a model, we did some analysis, okay? It was very simple analysis once we had this model. And based on this analysis, we reached a conclusion. And in this case, we also communicated this conclusion to what I would say was a pretty hostile audience to start with. An audience that kind of disagreed with sort of what I thought was the right course of action. So in a sense, for me, this is the essence of data science. Data science always has to start with sort of an end goal, a decision, something you're trying to achieve. It builds sort of choose A or choose B. It builds a simplified version of reality that allows us to fine-tune our intuition, do some analysis to calculation, and communicate this calculation to achieve buy-in and consensus to action. So if you think that this is sort of relevant and this is something worth doing, then I think you will like learning more about data science and enhancing your understanding of it. So in other words, data science is this attempt to tame the animal spirit. And for this, I have this quote by one of my heroes, John Maynard Keynes, who was an economist based at Cambridge. So he said that most business decisions are taken as a result of animal spirits, of spontaneous urge towards action rather than inaction. And remember, I mean, option number B has a lot more action to it, right? You're spinning, shooting, spinning, shooting, spinning, shooting, as opposed to action A, which is like, inaction. You just spin once and you sit passively hoping for the best. Instead, Maynard Keynes believes that decisions should be made as the outcome of weighted average of quantitative benefits multiplied by quantitative probabilities. So this is data science, taming the animal spirits. Okay, now you may be thinking that this is all nice and good if you're playing little sort of, games of chance, thought experiments and so forth. But how much value does this really add in the real world? Well, let me try to sort of address this head on by telling you a story. And the story involves a US retailer called Target. So I haven't worked with Target, I haven't worked for Target, but I have worked for one of their biggest equivalent, I would say, rather than competitors, Tesco's in the UK. So I've done a lot of work for them. So the story for Target starts with sort of the father of a teenage daughter walking into their local Tesco store and asking to speak to the manager. So the father was clearly very upset. So the manager comes to speak to him, and the father expresses how dissatisfied he is with Target because they send his daughter promotional material for pregnancy. And he was upset because he was accusing Target of glamorizing teenage pregnancy and therefore corrupting his daughter's morals, and demanded to know why Target thought that it was appropriate to send material like this to a 17-year-old girl. I mean, the manager apologized profusely, agreed with the customer that this was inappropriate, and promised to investigate to find out what has happened. And in doing the investigation, here's what he found out. He found out that back at the central offices, the data science team had created a pregnancy prediction tool. So the tool was targeting people's purchasing activities. And it also linked to public data about baby deliveries. So in the US, whenever a baby is delivered, this becomes public information. And it created a pregnancy index. So for example, when somebody starts buying unscented lotions, certain food supplements, when they stop buying alcohol when they used to in the past and so forth. These are all signs that that person is more likely to be pregnant. Now, why would Target want to do something like this? Well, I mean, the reason is that when somebody becomes pregnant, especially for the first time, they start buying a lot of stuff they were not buying before. Like anything that has to do with sort of, pregnancy fashion, to preparing for the arrival of the baby, to sort of after the baby arrives, purchasing anything from diapers to sort of, bottled milk and so forth. And why was it important to know that somebody would be pregnant for Target? Well, because if you know well in advance, you can start sending promotions, you can start sort of, capturing part of this wallet that's going to be opening wide for the arrival of the new baby. I know I have an 18-month daughter, so, it can be expensive. And be ahead of the competition, because the moment the baby is born, this is public information and they're inundated with offers. So once the algorithm sort of would predict somebody had a high probability of being pregnant, then Target would start sending promotional materials. For example, discounts for pregnancy wear, diapers, and so forth. Now, how do you think that customers responded when this happened at first? They click on it? Okay. Actually, that wasn't their first response. They were a little bit uncomfortable with this. I would say that's even a euphemism. They freaked out. I mean, they were like, you know, my parents don't know I'm pregnant. How does Target know I'm pregnant and they're sending me promotional material? So actually at the beginning, it rather backfired. But then, you know, Target is kind of, they're insisting. So they tried a different approach. And the different approach was to sort of, you know, bury the promotions for pregnancy stuff with other promotions that would clearly be relevant to a pregnant woman, like wine glasses or a lawnmower. So that made it sound like the promotions were random, and therefore it was less sort of, you know, spooky, less scary, less Big Brother-ish, if you like, and much more successful in converting demand from sort of promotions to purchases. So basically, this is exactly what has happened at Target. And out of this predictive modeling, they managed to sort of gain a large part of the sort of baby maternity market. And it was one of their fastest SKU categories over the last decade. Now back to my story. Sort of, you know, a week later, the manager called the father to apologize again for the inappropriate promotions that his daughter was sent. But this time, the father was not so angry. He was actually a little bit apologetic. So he said that he had a conversation with his daughter, and he found out about some events that have been happening in his household that he was not aware of. So this was a case of Target knowing before the father that his daughter was expecting. Okay, so how did Target manage to unleash value out of this predictive analytics? And I think, you know, in general, what does it take for a company to create value? I think it's helpful to think about it in 3 pillars. You need to have the right infrastructure. This is the infrastructure that allows you to capture, store, retrieve, and analyze data. So in Target's case, they had a very detailed customer purchasing database. And for every customer, they managed to create a unique customer ID that linked to the credit cards they were using, their loyalty cards, and they were also able to link this to public records of births and deliveries. Using this data, they were able to sort of create a more complete understanding of who is likely to be pregnant and when. In fact, they were so good at it that they were able to predict the delivery day with give or take 20 days. And if you look at the best medical models of predicting delivery based on sort of gestations and scans and so forth, they are only slightly more accurate. I know because healthcare is another area I work on. So the first thing is to have the infrastructure. The second is to have the tools and the methodology available. This is the tools that allow you to describe and understand the past, that is, which of your past customers were pregnant and how their purchasing habits changed. Predict the future, that is, you know, from the customers that you have now that you don't know if they're pregnant or not, which of them are pregnant and when are they going to deliver. And also provide insights and prescribe actions. So what kind of promotions are they more likely to respond to, and they're going to be more profitable to us. And even better if you can automate this whole decision so that once a certain behavior is observed in the data, without any human intervention, a certain action, a certain promotion is triggered. These are all things they were able to do well. But I would say perhaps the most important pillar is the third one, which is the culture and the processes. So Target's marketing department went to the data science team with this challenge. Can you come up with an algorithm to predict pregnancy? So if the marketing department didn't have the foresight, the intuition to understand that such a model would be viable, this would have never happened. Then sort of, you know, once the data science team came up with an algorithm that was predictive pregnancies, they had the right systems in place to deploy this solution and start sending out promotions. And perhaps the most important thing, they didn't just sort of, you know, stop there once the first solution was deployed, because the first solution was kind of a failure. They iterated. They continued improving both the predictive models, but also the way they were using these models to generate value. And I think in most organizations, if data science fails to make an impact, is usually the last part. I mean, questions are not asked. Solutions, if they're asked and they're solved, solutions tend to be deployed in a transactional manner where sort of, the first solution is rolled out and then we forget about it and we move on to solving something else without any feedback loops that are out for continuous improvement. And let me contrast the target story with the story of another organization I work with at the moment, and this is an NHS hospital. Sort of, a great sort of organization staffed by well-trained people that do their best to provide service to sort of, to critical service, I should say, to the population. So one of the very first projects I did with them was sort of trying to help them decide bed assignment. That is, the hospital was on a relatively rare sort of, situation where it had some extra money, and therefore it wanted to expand some of its units. So it asked the units to bid or make proposals for why they should get the money to have more beds. What do you think happened? Well, the surgery directorate put in a request for more surgical beds, and their justification was that surgeries were the most profitable operation the hospital was doing. So by having more surgeries, they would increase the hospital's revenue more than they would increase the costs, and therefore it was the right sort of investment to be made. The emergency department, they wanted more beds because emergency demand was growing by 7% per year for the last 3 years, and they just weren't coping with the amount of demand they were having. Maternity services, they wanted more beds because Target has been so successful in glamorizing teenage pregnancy. No, it's okay. So anyway, what I'm trying to say is it was pretty much a screaming match. And who got the beds? The emergency department got the beds. Why? Because the government was targeting waiting times for emergency departments, and if they didn't get the beds, the hospital would be embarrassed, it would be bad publicity, and they would be kind of penalized. So what was missing from this? I mean, nobody asked to see the data. Nobody asked to see the evidence. Why? Well, the infrastructure was kind of there, but so they were collecting information, but not with the mindset of using it to inform operational decisions, more with the mindset of using it for compliance and reimbursement. So for example, the data they were collecting didn't have much information about costing, for example. And if you want to use the data for sort of, any sorts of operational improvement, costing is kind of important. Tools and methods. I would say the hospital had about 200 people with the title data analyst. What was the job of these people? To ensure that the data entered the databases correctly, and it was used correctly for reimbursement, so they were getting paid for the work they were doing, and maybe a little bit of descriptive analytics. So try to describe what has happened in the past, how much growth the hospital had seen, and so forth. They had very little capability of forecasting future demands and even costing different services that the hospital was offering to figure out where were the biggest needs. But most importantly, the culture was missing. I mean, the hospital was run, I would say, by experienced managers that have been doing this for a while, but everyone had their own idiosyncratic style of managing. And there was a lot of repeat and trial and error. So in a sense, the hospital was missing the culture of asking data questions, the methodology to answer them, and even the infrastructure to answer them was kind of incomplete. Now, I'm optimistic about hospitals, and I think this is the area where data science will make a huge amount of impact in the near future. But I just want to contrast the sort of, the retail setting with where this is much more advanced to sort of, the healthcare and the hospital setting, where all of these are kind of missing. Okay, so you may be thinking, okay, I'm not in retail, I'm not in hospitals, so what does this mean for me? Well, I would say that data science has a role to play and an impact to make in most areas of business, from sort of understanding your customers better to, so in order to sort of, attract, retain, and better serve their needs, to pricing, managing promotions, figuring out what products to offer where, especially if you're working on a multi-channel sort of retail setting. A huge amount of value from data science can be gained from organizing internal operations more efficiently, from supply chain management, inventory planning, even operations like website design and website optimization. All of this can be informed through data science. HR management is one of the frontiers where data science is making a big impact right now. Some people think not necessarily for the best. For example, with artificial intelligence doing pre-screening of CVs in order to identify right candidates, leading to all sorts of issues around discrimination and perpetuating biases that have been prevalent in historical data. R&D and new product development, so the amount of data science put forward in R&D for, let's say, pharmaceutical products is staggering. Clinical trial optimization and so forth is a very active area of data science. But even companies like Zara, in designing and deploying new products, they have been using data science very extensively. And in fact, one of my colleagues in the operations department of LBS is working with them extensively to improve on this. So what I'm trying to say is that pretty much the limitations of data science are the limitations of our imagination as sort of data scientists and managers. Let me also sort of continue on this with sort of, taking data science a level further. So in all of these cases, in all of these sort of examples I've been thinking about and talking about, data science is used to do what the company has been doing, but a little bit better, a little bit more efficiently, a little bit more proactively to generate more value. Now, the next step to this is organizations that take the ability to do data science well and pivot the whole business model around this. So the biggest example I have for this is sort of, the case of Avocado. I mean, I suspect you know what Avocado is. I'm a pure online play retailer, so we'll go back into retailing. Which, by virtue of being purely online, it had a very good understanding of its customers because they did all of their purchasing on a digital channel. So their purchasing history was very much sort of recorded. Because it didn't have the burden of legacy physical stores, it had a blank slate on which it could design the fulfillment centers and the depots. This is a picture of a depot where you have robots working on a grid to try to, to actually assemble customers' orders and take them to the point where they can be loaded in a van and be sent to a customer. To sort of, optimizing truck loading and truck routing through busy cities with traffic and so forth. So at some point, Avocado became so good at understanding and predicting customers' needs and designing websites that were really fit for purpose in helping customers through the retail journey. They became really good and really efficient at online fulfillment and reducing the cost of fulfillment so much with their optimization tools that they thought, okay, let's become a technology company. Instead of selling groceries, let's sell technology that enables other organizations that don't have such a big footprint in online to create this really quickly. And I think the response of the stock market to this is kind of telling. So their market capitalization yesterday was 8.4 billion pounds on sales of 1.6 billion and actually no profit. They've never made a profit. Contrast this with a much more established player like Tesco, whose sales are 50 times or 45 times larger, but its market capitalization is only, 3 times larger. So in a sense, by pivoting to become a technology company, this loss-making retailer has managed to attract valuations associated with sort of, artificial intelligence startups. Now, you may think that this is sort of reflecting true value of data science. So data science has generated all of this value, and pivoting the business model to harness data science is the source of this. Or it could be a bubble And in fact, there's a lot of evidence to suggest that there is a bubble in artificial intelligence investment. So for example, last year there was estimated nearly 4,500 funding deals involving startups with the actual size of the amount of funding going to startups running in the hundreds of $1 billion. A lot of it, by the way, happening in China. You know, I wouldn't necessarily disagree with this sort of notion that this could be a bubble. That is, we have exuberant expectations of what data science and artificial intelligence can do, leading to an overflow of money into the industry, leading to valuations that are not in sync with fundamentals. In other words, a bubble. But is this really a problem? And in sort of, you know, thinking about whether this is a problem, I think answering two questions becomes important. The first question is whether these exuberant expectations, whether they're financing technological innovation versus financing speculation. And I think in this case, it's clear that the investments are financing new technology rather than speculation. The second question is whether this financing is done via equity or debt. And again, in this case, most of this funding is equity rather than debt. So contrast this with the subprime mortgage bubble. There, we had a problem of financing speculation using debt. So when the bubble burst, there was a big spillover in the real economy, and the actual investment amounted to sort of little improvement. While when you're investing in something that creates technology, like the dot-com bubble did in a sense, that left a legacy of sort of the internet, companies like Amazon, Google, and search engines. It created the backbone of sort of the smartphone technology that we're using now, and so forth. And when it did burst, because a lot of it was equity financed, it didn't have a huge negative impact on the rest of the economy. So to the extent that it is a bubble, I think it's a good bubble. Yes, sir.
Do you think it's a problem to the point where the market loses credibility and the big data and data science loses credibility to the big world, not to the specialists? You mentioned the internet bubble in 2000. After that, it looked like everything was bad and evil, and you shouldn't touch anything like that. And we are here 19 years later with some of the biggest companies who grew up from those.
Exactly.
That period. So it is a problem to the point where it loses credibility, i.e., it creates too much noise. Yes, too much noise. And people would start saying, why should I go into something? People who are not aware of what it is and how to use it, it would create a bit of tension among that large part, the vast majority of the people who have no idea of what we're talking about.
I think it's a concern, but I think any backlash will be transient, and the value, the fundamental value, to the extent that you believe it exists, will be validated. Exactly like the dot-com example you mentioned is a very good one. So there was this sort of, you know, backlash for a little bit of time, but, you know, fast forward 15 years later, 20 years later, the most valuable companies in the world are, you know, the Apples, the Googles, the Facebooks, and so forth, whose business model is data science. So if this bubble bursts and all of these startups lose money, is the ability to generate value by data science going to be diminished? No. I think what's going to be diminished is the exuberant expectations. So they will be recalibrated somewhere that's closer to reality. Maybe if the recalibration for a little bit is below reality, it will very quickly catch up. So I'm not so much worried about this. I think actually the legacy of this bubble bursting, when it bursts, will be new methods, a bunch of very well-trained sort of people that can take jobs in more productive industries, and perhaps sort of, you know, a wider acceptance of data science and artificial intelligence as a driving force of the economy. Yes?
A question is, I am surprised to see that this is such a big disproportion between the investments in China and in the US.
Yeah, isn't it interesting?
Is this the same proportion for all those years?
This is the split across different years. And, I mean, just by eyeballing the relative colors here, I would say yes.
Like this is identical proportion for all those years. And
It's not identical. If you see, it's actually growing. So it's less of a red here, more, maybe a little less here. So it's not the same, but and bear in mind that these are estimates. But by the way, most of my slides, if you go in the corner, I put references, which is where I got this information from. So I mean, you can look into this further if you want to understand this more. And most of my slides have this reference because, in a sense, we're an academic school. It's important to attribute sources.
What's the values? How's it worked out? Is it on the
funding
on PVP terms or pure dollar terms that translated at the going rate at that time? That makes a big difference on value rather than investment.
I don't remember out of the top of my head, and that's why I put the references there.
I'll give you time to ask.
I mean, you have the investment amount kind of.
Yes,
so you have a cycle and you know what the total values are at the point of coding machine, right? So
yeah, I mean, it's not my research. I wouldn't vouch for the methodology either, but I think it's indicative of where the world is moving.
I think to a large point, it depends what you call an AI company, right? I mean, a lot of, especially the Chinese companies are like conglomerates or like spin-outs of very big organizations. Is it a pure AI play? I think there is some interpretation to that.
Definitely.
You're probably going to cover it now, but you have to highlight the increasing profile of AI type of work that's happening in China, right?
Yes.
And there is a bit of an arms race happening. You may cover that later on, and a lot of it driven by the availability and quality of data that you have access to drive those technologies.
I mean,
there is an arms race at the national level, right?
Yep, which also informs debates about the regulation of data science and AIs. I think it's very interesting.
Some of it may reflect also national strategies of investing in national AI champions, not necessarily kind of what you would call a bubble based on pure market dynamics, right?
Okay.
Some of it, to me at least, reads like national champions being created to promote strategic technologies and then gaining access to cheaper money or kind of less
Could well be.
than normally be the case.
Yeah, I mean, in a sense, look, in many ways, I'm a data scientist and I'm much more comfortable talking about methods. So if anybody wants to talk about sort of, neural networks and how you do backpropagation, but I find the business model of artificial intelligence and how it's perceived in popular media and culture fascinating. In ways that nobody knew what I was doing 10 years ago when I was doing it, and now it's kind of everybody wants to talk about it and invest in it. So I find this fascinating. So I do want to sort of switch to sort of a little bit of trying to downplay this a little bit as well, because I did build up the case that data science can help with multiple areas of business and can even transform business models, but it also has limitations, and I think it's kind of important to acknowledge this. So for example, I mean, if you take one of the sort of biggest current topics in the UK, Brexit. How good is data science and AI predicting Brexit? Predicting the impact of it happening. And if you think it's terrible that data science and AI is not good at predicting these things, well, how good are we? How good are you? So in a sense, there are some questions out there that are fundamentally not well suited for data science to be answered, to be answering. And if I want to sort of give a sort of framework to thinking about what types of decisions could we think about throwing at data science, I think it's very helpful to think about it in sort of these two dimensions. The first has to do with the complexity of the decision we're trying to inform. So in a sense, in the target case, the situation was to try to predict whether somebody is pregnant or not. It's a kind of binary decision, so therefore complexity level is relatively low. Compare this with, say, driving a car. Driving a car involves multiple, highly complex decisions. So do I want to accelerate? Do I want to sort of, turn 3 degrees to the left, then accelerate, then 10 degrees to the right, and then deaccelerate? If I want to deaccelerate, by how much? How do I make, what do I need to do now in order to avoid the pedestrian that I think is going to cross the road in front of me, and so forth. So the complexity of the decision space. The second dimension that I think is very helpful to think about is how strong feedback loops are. And think about it like this. So if I make a mistake, in predicting somebody is pregnant, do I find out? Yes, I mean, the public records would say if somebody I predicted is pregnant, gave birth after, 9 months, and if, 10 months have passed and nothing has happened, I probably know I made a mistake. Contrast this, and similarly with driving a car. I mean, if I sort of, drive a car and I cause an accident, do I know that I caused an accident? Yes. Can I scrutinize the sequence of events that led to this accident happening and sort of, change the code so that next time I find myself in similar situation, I will avoid this? Yes. So contrast that with, say, the situation of recruitment. Okay? So if I don't hire somebody, do I find out if I made the right decision not to hire them? No, because I haven't hired them. Even if I hire them, it takes quite a bit of time to know if that person develops to sort of the leadership position I was hoping they would. I mean, sometimes if they're a really bad fit, I find out very quickly. But I mean, the difference between a good and an excellent sort of candidate takes such a long time to find out that I would say the feedback loops are weak. So if you are in a situation where you have low decision complexity and strong feedback loops, this is the area where data science is a no-brainer. You should be able to make an impact, and you should be able to automate decisions so that a lot of the things that were done imprecisely, slowly, manually, through trial and error could be automated and become sort of precise and unlock a lot of value. If you're in a situation with high decision complexity but strong feedback loops like self-driving cars, I think there's hope. And the hope is that as the technology of data science and artificial intelligence improves, sort of more and more things that we think are too complex now will start becoming sort of sufficiently low complexity to be able to make an impact. But as a first sort of recourse, I would say that decision augmentation should be possible through AI and artificial intelligence. So think of all of the driving aids that are becoming available in all of our cars now as standard. So that this is a first step towards trying to automate the process completely. So on the other extreme, where we have weak feedback loops, therefore we cannot train algorithms to make good decisions, and there's always going to be a subjective human element to the decision making. I think data science has a role to play, and this is to support decisions by providing sort of recommendations, perhaps highlighting salient features that a human operator may have missed, perhaps crunching a lot of complex information to reduce it to something that it's more digestible. But it's unlikely that an automated system will take over the decision making. And if you are in a world of high decision complexity with weak feedback loops, like, I don't know, politics or writing novels or designing welfare systems, I think it's not even helpful to think about data science. So just forget it. Okay, so I would always start from sort of, this corner, go down, up, in order to understand where to look for value. All right, so we talked about a lot of things. Let me just also try to bring it up to what does it mean for me. And by me, I don't mean me as a data scientist. By me, I mean somebody who's a manager who is sort of, data literate, but perhaps not a data scientist. So I would say, by and large, data science for you is an opportunity. It's an opportunity and not a threat. Why? Because I don't think it will replace human intuition and experience. even in the areas where there are low complexity with strong feedback loops, you still need a strong amount of human intuition, experience, and contextual understanding in order to make sure you are asking the right questions, you are implementing the right approach to solving them, and you've built the feedback loops that allow for continuous improvement. But I think it's important to learn how to think like a data scientist. So you could hire an expert, but you need to be able to talk to them. So therefore, I think it's becoming increasingly important to understand what data science methods can do for you. And I'm thinking of things like data visualization, supervised learning for predictive and classification models, and supervised learning to sort of, try to see patterns in data that are not obvious. Things around simulation and optimization to allow to squeeze out efficiency of systems, even estimating models that are based on neural networks and deep learning, which are sort of, models inspired by the way the human mind is wired. The era of data science being something that's done in embasement in an organization is kind of over. I think data science is sort of, rising up through the ranks of organizations very quickly. And in order to unleash its value for companies, but also for personal career development, I think it's important to invest in these skills. That's why at LBS we're developing a large number of electives for our MBA students, because we think it's impossible for an MBA student to consider their education complete without at least a high-level understanding of all of this. So let me finish with some homework, like I finish all of my lectures. My colleagues and I maintain a website on the London Business School Review that talks about analytics and big data. So we talk about trends we see and how big data, data science, artificial intelligence is trying to make an impact in the world, both the good impact and the perhaps not so good impact. So by all means, go and have a look. We will make these slides available, so if you want to look at any of the references that I've been talking about, you can just click on the slides. But I want you to sort of, finish this session by reflecting whether there is one opportunity for your organization where data science can create a value. So what is this opportunity? What are the barriers that prevent your organization from creating this value? Why haven't you captured value out of data science in this particular opportunity yet? What are you missing? Is it the culture? Is it the processes? Is it access to methods? Is it the data infrastructure? And what can you do to resolve this? And it would be great if at LBS we could do something to help you unlock value out of data science, either through the courses we offer, but also perhaps more importantly through the research we do. Because the research we do tries to sort of generate new methods that solve problems that have not been solved before, or apply existing methods to new problems in innovative new ways that, in addition to solving the problem, generate knowledge. So I would love to hear from you and what the problems your organization's facing are and what we can do to solve them. So please stay in touch. I'm on most social media. I also actually check email as well. So thank you, and it's been an absolute pleasure speaking with you for the last hour or so. Thank you.